Hello, everyone. Today we'll be discussing this very important question that came in June 2019. You can actually find this in the vectors folder. So there's a worksheet that is labeled out as practice worksheet number 4. So you'll be able to see this question over there as well. Now, they've given us the dimensions over here. So they've given us that CD equals A, DE equals B, and similarly FC equals A minus B. For my convenience, and this is something I highly suggest as well, in your exam, I would expect that you label this out with your pencil. So CD is given to you as A. Similarly, this entire side is given to you as B. And finally, FC is given to you as A minus B. The first part of the question says find or express FE in terms of A and B. So they're asking us to figure out this side. Now, whenever it comes to these kind of questions, I know that you can solve this directly as well. I would highly suggest still writing down the entire path. So that's going to be FC plus CD plus DE. If I were to input the values, that's going to be A minus B plus A plus B, and minus B and plus B cancels out, leaving you with just 2A as my final answer for the first part. Now, again, that's the easy part. The second part is where the question becomes a little more cumbersome. So it says M is the midpoint of DE. That means this part over here is actually equally divided within this line. So can I say that D to M is going to be half B? Because this whole thing was B, right? In a similar way, ME is also half B as well. Now the next part of the question says X is a point on FM such that Fx ratio XM equals N ratio N. That means this side over here is actually N, F to X. And similarly, X to M is given to you as 1. Only this side. Now, this does require you to know the concept of ratios. And I'm hoping by now you already know this. This part over here is the most important one. It says CXE is a straight line. Now, whenever it comes to these kind of questions, that means this is going to be my basis. This is what I have to solve. And I remember that if, as in I have already explained this concept, when I talk about CXE, so there are 3 points over here, C, X, and E. And it says that they all lie in a straight line. I know that there's no straight line over here, but we can actually draw this out as well. So they do lie in a straight line if you think about it. Now we just need to prove it. And they've already stated this as a fact, so there's nothing to prove. We just need to figure out the value for N. Now, if you want to break this down, there's 3 ways in which I can write down this expression. I can say CX is parallel to XE, or maybe I can say CX is parallel to CE. And finally, I can write down XE is parallel to CE. These are the 3 expressions that I have, which are equally possible. That means you can use the first one, second one, third one. It totally depends on you. Although you should always try to select something that's probably requires less working. So if I think about the first part over here, it says CX. How do I go from point C to point X? There's 2 ways in which I can reach, as in from C to X. Either I go in this direction, or I go in this direction, from C to F and then F to X. And similarly, for X to E, again, you'll first have to go from X to M and then M to E. Again, that's one way of doing it. If you check out the second part over here, it says CX is parallel to CE. Now, of course, we already have, as I discussed, how we can reach from C point to X point. And if you think about it, CE is something that you can easily, as in go from C to D and then D to E. The concept that I'm trying to teach you over here is that your task should be that you have to take the least amount of variables. So if I were to take this expression over here, CX equals to, you can say, K times CE. If I were to take this as my, as an equation and then solve, you'll realize that you can easily figure out CE in terms of just, as in the variables that they've given us. So we don't need to introduce anything else. That means in this case over here, that's going to be from C point to E point. Let me just make this a little more clear for you. So C to D was given to you as A, and similarly, this was given to you as B. So I can say that has to be A plus B. Easy. But now comes the challenging part, which is CX. Now, to go from C to X, again, it totally depends on you. I'm choosing this. C to F, and that's going to be, so they have given us F to C, which is A minus B. So can I say that if I want to go from C to X, then, well, that has to be C to F, and then similarly, F to X. Now, what exactly is C to F? Well, if they've given us FC, can I say that's going to be minus A plus B? And similarly, then you're having Fx. So I do need to figure out Fx over here as well. Now, if I want to figure out Fx, and if I were to label out the ratios that we had as well, this was given to you as n, and this side was given to you as 1. Can I say that in this case, Fx is going to be n over the total that we have for that line, which is n plus 1, times the whole line, which is Fm. So this is what we have. Now, again, the next challenge, I wouldn't say this is a challenge. I would say this is a 6-mark question. So it requires multiple steps. And when you write down these equations, that's just going to lead you in the correct way. So now I know that I have to figure out Fm as well. Now, if you think carefully, you already figured out in the first part Fe, which came out as 2a. And you also knew that m is the midpoint, which clearly indicated that this has to be half b. Please be very careful about the directions. You mess up the directions, the whole question goes wrong. That's going to be n over n plus 1. I'm just going to directly substitute. This will be 2a minus 1 over 2b. Are we supposed to expand it? I mean, you could. I'm just not going to do it right now. I will eventually, but not at this point. So now I know that, I have bit of, as an fx. So I can actually use this equation over here. And I can eventually just plug it into this equation. So if I were to plug this in, can I say that has to be minus a plus b, and then we had plus fx, which is this thing that we just figured out. So that's going to be plus n over n plus 1. Then we have in brackets 2a minus 1 over 2b. And then we have equals to this side of the equation. So equals to k a plus b. I hope you're all with me right now. If not, then I would expect you to pause this video and watch it from the very beginning. Now let's try to expand it. If I did, that's going to give me minus a plus b plus n over n plus 1 dot 2a. I multiply this thing with 2a, and similarly, I multiply this with minus 1 over 2b as well. And if I did, that's going to give me minus n over n plus 1, and then we have 1 over 2b equals to, let's expand this as well. So that's going to be ka plus kb. If I were to just highlight the a values that I'm having, this is a, this part over here contains a, and this part over here contains a. Since we are dealing with vectors and we know that this expression in between, what does that mean? Equal. So I know that the left side has to be equal to my right side, which means that this a that I've highlighted, we can write this down separately. So I can say, well, that has to be minus a plus n over n plus 1 dot 2a is equal to ka. If I were to cancel out the a's over here, or just take them common out, ideally, you don't need to even write this down as well. I just do it because I don't want you to get confused. So that's going to leave me with minus 1 plus n over n plus 1. And then we have dot 2 is equal to k. Can I multiply this 2 with n? Of course I can. So that's going to be minus 1 plus 2n over n plus 1 equals to k. This is one expression that I end up getting. Now, in a similar way, I'll compare my b part as well, or I should say the b equations that I will be forming out of this. So now I could say, well, this is b, and well, this is b. Ignore my bad handwriting. So that has to be plus b, and then similarly minus n over n plus 1 dot 1 over 2b is equal to kb. Like I said, you can just cancel out the b. That's going to be 1 minus n over n plus 1, 1 over 2 is equal to just k. If I were to just multiply this, that's going to be 1 minus n over n plus 1 times 2 is equal to k. So if you think about it, everyone, you'll realize that now you have two equations which represent k. So if these two equations, they represent k, can I say they both are equal to one another? And if they are both equal to one another, that means I can actually compute both of them. So that's going to be minus 1 plus 2n over n plus 1 is equal to 1 minus n over 2n plus 1. You should move the constants on one side. And if I do, well, this goes over here, and this is going to move this on this side. Well, that has to be n over 2n plus 1. And then we have this equation plus 2n over n plus 1 is equal to 1. And then this would be plus 1. So 1 plus 1 is 2. And you can see that you would have to take the common denominator. So we can multiply this by 2. We can also multiply this by 2. If I did, that means now my common denominator is 2 brackets n plus 1. In the numerator, we'll be having n plus 4n. Can I say that's 5n? And then you can just make this go on the other side. If you were to cross multiply, that's going to be 4n plus 1. If I start expanding this, that's going to be 4n plus 4, and that's going to be 5n. You make the 4n go on this side, you end up getting the value of n as 4. And that's it. This is what the question wanted. I hope this question makes sense. We'll continue with this, probably with some other question in the next video. Till then, adios.